Hey, happy Sunday. This is PFG.Live, the podcast that iterates about iterating. And welcome aboard. We have a bunch of cool people here in the Discord. Welcome to Dale, Josh, Derv, Carl, Bill, Warren, DBX, Evils, Arstead. More are coming in. Feel free to have the snacks in the front room. We're getting reports from, let's see, Warren Jones, my neighbor to the north, says in Sutton, New Hampshire, the weather is the same as Spencer's, which, by the way, is 80 degrees Fahrenheit, 49% relative humidity, winds out of the south-southwest at 5 miles an hour. Dale reports 7 degrees science and sunny from the overnight low of -5 in the Edmonton of Alberta. Evils says that it's approximately 21.4 degrees in his 21.4 degree room. Josh says it's wet in southern Manitoba, where the winds are 350 at 16, gusting 25, temperature 08, dew point 07. That's cold and damp. And peak wind was 340 at 30. Holy cow. Bill Olney says Rome, New York is 78 degrees Frankenstein and sunny. Welcome aboard, Bill. Arstead says 82 degrees Fahrenheit and 38% relative humidity in Peoria, Illinois. It is drying out, isn't it? I see that around here. Also, over on the YouTube side, Carl Tauber, my neighbor to the south, says 75 degrees and bright sunshine in Rhode Island, and that is true. CJ Stevens says it's 80 degrees and very sunny in East Tennessee, and he says hi. Ted Hyde from Casa Frog Pro Resources in Eustis, Florida. Eustis, Florida? It's Eustis, Florida. Is that your typo or mine? He says that it's winds are 110 at 13, gusting 19 knots, visibility 10 miles, scattered at 3,300, broken at 6,000, temperature 31, dew point 23, altimeter 3004. Welcome. DBX says it's 20 degrees plus Fahrenheit, hotter than it should be in October here in the Northeast. Isn't that weird? It's weird. Go figure. But I'll tell you, I will be going outside and sitting around and drooling on myself, staring at the sunshine later, and I will enjoy it. Welcome aboard. Busy day this morning. I was wrapping up PFG Stones. We have an unusual surge of orders specifically for 4-inch PFG Stones. I don't know why. Did somebody talk about 4-inch PFG Stones somewhere? Because everybody wanted them. And you know what? You're all going to get them because I worked hard. Yeah, so community notes. I don't think there's many community notes this morning. I have a funny one from my friend Doug. Let's see if I can get this up for you. Doug Chen, who we've mentioned a bunch, sends me this picture from somewhere, Cape May, New Jersey, I believe. He says this is an eagle perch in Cape May, New Jersey, which I recognize by the structure itself. And you don't see many antenna eagle perches, but there you go. That's Bob and Fred. Hi, Bob. Hi, Fred. Let's see. Yeah, it is pretty warm. I get a call from a buddy of mine, and he says, "Hey, did you get those O-rings for me?" And I'm like, "Oh, I totally forgot. I'm sorry." And I said, "This is my friend Steve, one of my friends, Steve, and he's a photographer, and he needed an adapter between a lens and a lens board for one of his large format cameras. And he had asked me a couple of weeks ago to order an O-ring for him. And I placed an order for McMaster-Carr on Thursday, totally forgot. He was up north. And I said, "Oh, Steve, I'm sorry, I forgot." I said, "What are you using it for?" Because I didn't know at the time. And he says, "Oh, I'm using it as an adapter between my lens and my lens board." I'm like, "You should have said something. Give me the dimensions." So he gives me the dimensions, and I write it down, and I text him back in about 12 minutes. I said, it's all ready. It's ready to go. I 3D printed it. And this is the beauty of 3D printing. So my plan was, I'm going to 3D print this ring. I'm going to then measure it, and I'm going to go back to my model, dial in the corrections, and then I'll print it again. So I did it. I did that. I modeled the thing up. I sent it down to the H2D. It was all loaded up with Polysonic PLA Pro, and I hit the button, and in 6 minutes it was done. So I go downstairs and I grab it, and I get the old calipers out, and I start looking at it. And what do you know? I didn't need to do anything. It was completely done. So I printed a couple more for him for good measure, and I delivered it. But the beauty of the 3D printer is you have something in your hands like right now. And if it's not perfect, you could make it better. So that's okay. But we delivered the Heyman project on time, and Steve was a happy guy. So that was the good news from there. What else is going on here? We're going to talk today a little bit about this project that's been consuming me so that I could bring it in for a landing, and I'm happy to report I think we're bringing it in for a landing because it's working. The hygrometer that's measuring temperature and humidity that goes into every AMS has been mechanically designed after iterations, electrically designed after iterations, and software is still iterating. And we're going to share that a little bit today. And I don't know if anybody got the little software hack in the thumbnail, but the title of the podcast was done in Lisp. So there's about 4 of you out there that got that. So I will share with you some of the iterations that we have gone through and talk about some ideas. And then I think we may have time today at the end for an open AMA, and you guys are welcome to gather your thoughts for any questions you might have, and we'll get on with that. Big shout out to my kiddo, Jared, got a project done that he wanted to do. So I think I might have mentioned it last week that Jared says to me, hey, Dad, I want to make a lamp. I got this design in my head for a lamp. And I'm like, well, why are you making a lamp? Why don't, we could buy a lamp. And he says, no, I want to make a lamp. So it was a design project. And he explains to me what he wants. And it's this 3D print, which we figured out was going to take 2 days on the printer. So we did it, and he did it, and he was successful, not without pain and torture, but it ended up being a 1 day, 17-hour print in PETG Natural from eSun on the H2D. And this was P4 that was successful, a pretty common number in the P series. And we had problems in the beginning, and my friend Doug made some suggestions, and Dale made suggestions, and we got a lot of input. And then finally, on the last go around, we did a couple of key things. Number one is we gave it a brim. It didn't seem like it needed it, but we gave it a brim. The second thing we did is we lowered the temperature. The generic PETG profile was 255C at the nozzle, and the material we were using was rated at 240 to 250. So Jared said, let's lower that into the center of that range. And I said, okay, let's do that. And we did run some tests. So we finally did that, finally worked. and every couple of hours we had to do a trick to clear the nozzle. I don't think I talked about this last week, but it turns out on the H2D, actually on any of the Bamboo printers, if you walk up to the printer and you say pause the print, maybe you see a piece of stuff on the plate, you want to go in there and grab it, you can pause the print, and then you can restart the print. Well, the trick is, if you pause it and then immediately restart it, or not immediately, it will bring its nozzle back up to temperature and do a nose wipe. It will do a nozzle wipe. So we were seeing this stuff gather up on the nozzle, so it was just pause and then resume. And it would go and do a nose wipe and continue the print. That's the hack. So it's a really quick manual interaction. Unfortunately, we had to do that every few hours because through this, 1 day, 17-hour print. And it worked, and it saved the day. And we were able to get through this print, and it took very little cleaning up, a little teeny bit of stringing around. We had to hit it, and Jared hit it with some, I gave him some effectively Scotch-Brite pads, and it was done. And he put it together, and it went snap, 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 just like he designed it. And there it is. So I just very proud of Jared. Designed a project, built a project, using the project, and it's working out really well. So good job, buddy. What else happened this week besides completely obsessing on this project? A little bit of antenna work this week. My buddy Steve, yet another Steve, I was up in Maine helping him out, and here we are. I'm on the ground. I was on ground crew helping him get some antenna stuff done. Details another day or another channel, but that was just part of this week's missions. While I was down there, Steve showed me this stuff. This is a paint called Black 4.0, and it's called the blackest paint in the universe, and it was pretty cool. So the this one's for you, Evils. There's the contents, and I don't know if I could do it justice, but it says contains tetrahydro-1346, tetra kiss hydroxymethyl imidazo 45. You know what? I think Carl, you're going to have to read this, and we're going to have to go over this. It is the longest chemical name I've ever seen in my life. I do not want to eat it, but there it is, the blackest paint in the universe. If you look that up, you can order it. Do we all owe a royalty to Stuart Semple for looking at that image? No. As long as the one guy he doesn't like doesn't look at that image, then we're okay. There's a story behind this, folks, which we will not dive into. Oh, and the website, I should show you the website because you might be interested in this. The website is a little too zoomed in here. culturehustle.com. culturehustle.com. It is a good story. It's a crazy story, and I won't bore you with it. What else? Yeah, those were the main things that happened this week. I have another story. Again, hashtag not sponsored. I walk into Airgas, and they've got this welder sitting there, and it's made by a company called Forney, Forney. And I said, "What's the story on this?" He says, "Well, the guy who used to be the Miller rep left Miller and went to work for this company and came in with this. So it's a new company, new welder. I know nothing about this, but it's a multi-process MIG TIG stick machine for $18.50. So there you go. Just reporting the news. No personal experience, and it is very green. I will say that. So if anybody knows about that, you could let us know. And that brings us to our our present topic, which is this this magnificent project, which we've been working on, which is the hygrometer. I'm happy to say that we have a working version of the electronics, of the software, and of the housing, and they're all playing very nicely together, and it's working out quite well. There's still some more testing to do, but I'm at the point where I'm ready to do a build. So I have purchased, I certainly have enough stuff to build 5, but we're working on building 10. So that is in the works. I placed an order, and thank you, DBX. I placed an order, and we should be getting additional parts for the 10-piece build real soon now. CJ Stevens says most multi-process welders are decent at everything, but usually not great at anything. So I used to say that I don't want an amphibious flying car, because just like you said, it doesn't do anything very well. But, you know, some people have a limited budget and they want to do that, and it's a hard argument to, you know, get around. But there you go. It's just a new kid on the block. I'm just raising awareness, sir. Just raising awareness. In sort of related news, I was able to order the high flow nozzles for the H2D. So the high flow nozzles have an interesting structure in the heated section, in the hot end, that apparently gets more heat into the filament, and you're able to deliver a higher volume of filament, thus the name high flow. And I broke down and ordered the nozzles in each size. So they come in 0.4, 0.6, 0.8. And I did start using them, but I was unable to prove that one is significantly different from the other with the normal settings. So I think you have to go in and start making profiles that really push them to appreciate it. Although Dale said that general print quality goes up with the high flow nozzles. I will report as I use them, but we do have them installed, and we did start using them for the housings for the KP hygrometer. Evil says, how much of a step up is high flow 0.4 versus non-high flow 0.6? I don't know. This is the first non-0.4 nozzle I ever bought for the H2D, so I don't have any experience. Now, going back in history, I will point out that the original trays for the PFG Stones ultimately were made on a TAS 6 printer with a 0.6 nozzle, and it was a pretty good setup. And then when I went to the Prusas, I decided to go just 3 Prusas. I went away from the 0.6, and I haven't been back since. So that was a couple of years ago. But we'll see. We'll see what happens. So those came in. Those are installed. They're being printed. In fact, this run of cases for the hygrometer, I did them all with the high flow nozzle, and they seem to be fine. They seem to be. If I handed you that box and told you that half of them were with the high flow nozzle and half of them with the regular nozzle, I don't think you could tell the difference. There was no difference in print time because I didn't turn up the knobs. Okay, I did have to tell the printer, or actually the printer was able to detect which nozzles it had on it, but nothing amazing happened. Dale says, I find the 0.6 will decrease print time around 20%. So if you're using bamboo filaments, and you just select the bamboo filament profile, then it will push it, okay? Just like the PETG HF, when that came out, you downloaded the PETG HF profile and it cranked it right up. But I'm using the Polymaker filament, and I cannot get the combination I need of Polymaker, H2D, and the high flow nozzle in a manufacturer supplied profile. So I'm going to have to make something. And my plan is to steal, is that the right word? To steal the profile from the Bamboo Tough Plus PLA. I think that's going to be mighty close with the high flow nozzle, and then see how that works. I haven't done the test yet. And my goal is not necessarily like super high speed, but it'll be very interesting. Yeah, I gotcha. So Dale was saying that the ratio between the 0.6 nozzle to the 0.4 nozzle was 20% reduction in print time, which is cool. We'll play with it. Back to that new welder. Warren Jones says Forney has been around for many years, mostly selling supplies, grinding wheels, electrode holders, wire brushes, stick electrodes, for example. To my knowledge, he says, they just recently started selling machines, and a good multi-process welder does everything a good multi-process welder does everything it is designed to do quite well. So we'll see what happens. If you went to get the same thing in blue, I think you end up paying double. And of course, by that I mean Miller, right? No question, it would be double. So there's some developments there, and that's pretty cool. Well, we'll see. I will report what I hear. I have a Miller, not a multi-process. I have two different welders, and I don't need any more for the amount of welding I do. I'm very happy with what I have. So let's see, what else? Oh, well, here's a good one. You don't see this every day. I looked up at my low flow air, drying system and the 10 PSI manifold, or the low pressure manifold, and I saw this. So if you're on audio, I looked up at my gauge to see a bent pin or a bent indicator on it. And it turns out that when my solenoid opens on the low flow system to turn it on, that meter was getting slammed. The gauge was getting slammed, and it literally was bending the pin. I don't know, Evils. I have no idea. I'll report back. So we ordered some new parts, and of course it makes a lot of sense. You've got 100 PSI in front of a regulator. The solenoid valve on the high pressure side turns on, and everything happens quickly, and that undamped gauge just slammed, and the indicator bent. That'll learn you, right? So I placed an order for a liquid-filled gauge. I was talking to Dale at the time. That's on the way, plus a little orifice. They sell a 4,000th diameter orifice to go in front of the gauges specifically to prevent this. It slows down the flow, and it should work. I need a flow control valve. So, so this goes regulator, manifold, 10,000ths orifice, and out. Okay, the gauge was on the manifold, and there was no tempering the pulse. So I think we're going to be okay now. CJ Stevens says, not bashing imports. My TIG is a prime weld, which is an import, and I love it. Cool. Let's see. Tucker says 80 degrees Fahrenheit and sunny in Buffalo, New York. Welcome aboard, sir. I am not even going to mention that you're late. I'm not going to mention it. So let's see. I think that's the catch-up on this week before we dive into the topic. Yeah, nothing else happened this week. Absolutely nothing. So let's get to work. There we go. So many lessons learned this week. I ended up, we're going to talk first about the case of the unit. So this is the case that I'm holding in my hands here is P14. Now, I know what you're thinking. P14, that's a big number. It is a big number. And what happens is you start building these things and you go and say, oh, you're downstairs in the 3D printing department and you put the two halves together and they work great, and you run upstairs and you start populating it with the processor board, the battery, right? Here's where the battery goes. I'll show you that. And the sensor and all that stuff. And it was all working out so well. And then you realize, oh yeah, there's some wiring to be done. Well, then you start wiring. Okay? And you find out that there's no room. there's basically a traffic jam of wires. Now we did intentionally design some wire paths, but we didn't get all the wire paths. And in fact, this lovely battery from Adafruit is an 18650 battery with a cable that looks like 100 millimeters, and then their power connector. Well, you have to put this cable somewhere. And that led to making some modifications. Anyway, the short story is, every time you learn one of those things, you run back upstairs, you go on Fusion, and you scratch your head and you make some changes. And you end up with another design. But you make the changes, you spend whatever time you want to spend, and then you hit print. And then in an hour and a half, you have another thing to test. That is awesome. So that I went around that loop a bunch of times, and when I thought I was done, I ended up with a case where I only have 2 screws available to hold the top and bottom together, and they're both in the upper half of the case because reasons, okay? And the bottom was not holding together very well. So I designed a little clasp, or a clasp, hook, what would you call it? But the bottom half has a hook shape, little part to the lip, and then there's a little bump out on the top half, and when you put it together, you kind of hinge it on that edge, and they lock together, and now the back is locked without the screws. And then after P14, which was a grand success, I actually made that twice as wide as P14, and that's where we got to P15. But also, we added a different way of putting the regulator board in. So now the regulator board slides in to some holders, does not require a screw, and that clears out a whole bunch of room at the base of the battery so that we can handle the wiring. So wiring handled, case attachment handled, it all looks good. So we went 15 rounds with the cases, and that's what led to this picture that you saw in the thumbnail of all the learning that was done in the 3D printing. If this was a machined part, chances are we wouldn't have done it this way. We would have, spent more time in simulation, or we would have drawn in the wires and did all that stuff. But because we have the 3D printer, we're able to very quickly go in. In fact, let me show you. When I came up with the idea of the little clasp at the back of the case, instead of printing the whole case, I just printed this little part of the case. So I was able to go in, and Dale reminded me how to do it in the slicer, and just slice off the back part of the case and just print that. And then if you look in there real closely, you can see the little latch, and I printed it and it worked great. So excuse me, the ability to 3D print something that you're designing quickly is absolutely fantastic. Ted says, that's only 15? That's incredible. I usually don't notice I'm in a feature creep hole until 20. Right. And I'm okay. I'm totally okay with it. In fact, this tray of parts is the only evidence that we went, 15 rounds. And now, as we start cranking out those cases, they're fantastic. Evil says, think of all the microplastics that could have been saved if all of this was done by a design team thinking about it for a week, having individually wrapped snacks in the cafeteria. Yeah, I'll think about that. Thank you, but no thank you. And by the way, no AI was used in the design of that part. Just pointing that out. And in that picture, you could see the very earliest thing that I printed, which was the size of the early desiccant boxes that we originally used in the AMSs. So I figured, that's the size of the box that I have to work with. Let me print a size reference. Well, that size reference, which I have right here, that size reference informed me that the space available in the AMS2 was several millimeters smaller than the space available in the AMS1. So printing this physical size checker was huge. And as you can see, it's a hollow print, minimum print time. In fact, when I did it again and I printed what is now our final shape, I put my oval in the bottom just to not use up filament. So this was the size reference for what we have now. And in fact, I believe I took off a couple of millimeters. Yeah, I took off, I think, 2 millimeters from the top of that. But that was a very successful size reference. So printing a size reference costs you like very, very little filament, at least in this case, and not much time. And then you have something physical to shove in the space of a device. Otherwise, you might be chasing your tail and have a surprise later after you've spent a lot of time and money. So that was the purpose of that. So another feature of this design, is the sensor goes up here on this post. I don't have one in this particular box. And it's way up high. It's as far from the processor board as you can get it. And there's a lot of air holes in the case all around it. And that worked out pretty well. And then I put a fan in. So the fan I found is this little tiny 18 millimeter. Look at this little cute thing. This little 18 millimeter fan, and it goes into the case right here. And then some people said to me, well, why, you don't have to do that. Why are you doing that? So I brought with me today a document which I downloaded from Sensorion. This is called the Design Guide for Humidity and Temperature Sensors. And they said some very interesting things. They warned against things like having a dead volume around the sensor. This is full of Lisp references there, Evils. They warn against having a dead volume around the sensor. They encourage having a large opening around the sensor. They encourage separating the sensor from heat sources and maybe putting a shield between the two. They encourage putting a PC board cutout around the sensor, which, by the way, the Adafruit board does have. They designed the board correctly. And there's a statement in this document which tells the whole story. If the sensor is placed in a location that is not representative of the overall environment, the readings it provides may not be accurate. That sounds pretty obvious, but if I didn't like the way the sensors were being put in some of the commercial products where they put a little hole in front of it and call it good. So I think we did a really good job. And then I want to save that for a little later. There's a picture in here of airflow across the sensor. And there was a question about whether we should be blowing air across the sensor. And in fact, here it is, their picture in the design guide. And it is, yes, please, you move the air across the sensor. And they say, if there is airflow over the sensor, see figure 13, the air inside of the dead volume is exchanged constantly. Such a design-in is favorable in terms of response times. Even if there is no defined flow, a device designed with multiple openings, sound familiar, and possible airflow, sound familiar, is preferred. If there is no possibility to realize a design with airflow directly over the sensor, then the following points become important. And then they go on paragraph after paragraph about how to, deal with that. But their happiest place is to have a positive airflow over the sensor, thus the little fan. So I'm very excited about the fact that the fan is working. The software is able to turn the fan on or off. And then when it goes into sleep mode, the fan is also off and everything's quiet. Right now I have in the lab a group of sensors sitting on an aluminum tray, and they have been taking data now for a couple of days. And I have been getting some very interesting results. Let's see if I get a picture of it for you. One of the results is that we have a group of 3 sensors which are of particular interest. One of them is my old featherboard, the little red featherboard workstation running the Sensorion SHT45 sensor. Another one is one of my first prototypes in the black box, which doesn't have a fan but is running the SHT45 sensor. And the third one is in my black box with the fan running the latest software, or the then latest software, and the fan. The 2 no fan units, which are physically very different, agree with each other to within 0.1% on both, on relative humidity, and within 0.1 degree on temperature. Okay? The one with the fan agrees with the other 2 within 0.1 degree on temperature, but the relative humidity is coming in 3% lower. Now, why? I don't know yet. I have a few more experiments, but it may prove to me one of several things. Number one, the sensor could be out of calibration enough to cause a 3% difference. That's a possibility. Number two, it could be that the fan moving the air is solving a problem, and you're measuring an actual, you're making a better measurement of the relative humidity. That's a possibility. And it could be another possibility that we haven't thought of. The software is sufficiently different. There's one other trick that I'm doing, I'll tell you in a second, that may also be the cause of the difference. So somewhere in the, in my interactions with my buddy Chat, did I introduce you to Chat? While I was writing software, I was getting help from my buddy Chat. And it said, oh, you should take a reading and throw the first reading out and then take another reading. And I said, that sounds ridiculous. I found it in this document. So it actually was correct. So in the new software, we do that. We do a bunch of, best practices things, including taking the first reading and throwing it out, and then using the second reading after 200 milliseconds, which is generous. No, I take it back. I think it's 20 milliseconds. It's more than the number in the document. So Bill says, have you tried Claude for coding? I have had less problems using it than Chat. So I have not gone down that rabbit hole, and you're not the first person to recommend Claude AI for coding. I'm not a coder. So I'm not sure the differences would be, I would appreciate, but it has been useful to use ChatGPT for coding. It has given me some good ideas. In fact, it's a chipper little helper. It's like, hey, would you like, based on what I just told you, how about I just rewrite it for you? And I'm like, no. Just tell me what you want me to change. I'm going to change it. That's how you learn. I didn't want it to just code everything for me. So that's kind of how I'm using the tool. But getting back to the sensor, that was a very good suggestion. So that's in there. And there's a few other, Tuck says that chat has helped him a lot too, I assume for the featherboard coding. It's absolutely good. But I want to know why, and I want to get the skill of how to do the code. So I'm using it as a helper, but I'm like, just stand next to me and tell me what to do so that I can get used to doing it. So the unit that's running right now in the lab, it's called KP7 and KP8. KP7 is in the black box, no fan, and not quite the latest software. And KP8 is running with the fan and the then latest software. And I've been tracking both of them for days. Very good data, very interesting. I will report back when I learn where the 3% difference comes from. Here's my plan. I plan on taking 7 offline, giving it the fan, giving it the latest software, and then putting it back. Okay. And if the 3% difference goes away, we'll know that it was the software and the methodology making it go away, possibly the fan. And then we could do another experiment where we then take those 2 units and on KP7, just don't use the fan. Just tell it no fan and repeat the experiment. And eventually we will understand what's going on. But I see a very clear path to a finished sensor. I almost said the word product because I don't know that this is going to be a product. I think this is an internal product. But that's a question to be answered later. But so that was so software iterations have been happening also. The beauty of using the featherboards is you plug them in, they show up as a drive, you drag your new software to it, it installs it, reboots it, and runs. It's not painful to put new software on it. And just because some of you are going to ask me, I use Virtual Studio, Microsoft Virtual Studio Editor to do the code editing, and it works great. I'm learning a lot. I'm a novice at programming, but I'm starting to get pretty happy with the results. And then the other thing that's happening is the literal electronics wiring. So in the featherboard, you could take an output pin. In my case, it's A0, okay? And I could take pin A0, and you could declare it to be an input or an output. So, of course, I declared it to be an output. So now it's a driven pin. And now you can drive it high or drive it low. Then I found the Adafruit board, which is a 5-volt boost regulator. In other words, you put anything into it from 2 to 5 volts. It uses a chip from TI. Hey, Taunus Mechanics. He's waving. I'm waving back. Welcome aboard, sir. And it has an enable pin. So I'm using the enable pin to turn that regulator on or off to drive the fan, which is a 5-volt fan. That's interesting because what I haven't yet done is check the quiescent current of the regulator when the thing is in sleep mode. The first thing I discovered was it needs a pull down. So I added a pull down resistor so it actually turned off when the thing went to sleep because it was staying on. I'm like, okay, well, that's not a difficult lesson. After I put the pull down resistor in there, it went off during sleep, just like we're supposed to. But I have not yet made a measurement of the current, and I don't know that I'm going to see a small enough number to make me happy. Stay tuned. So the next, amongst the tests that are coming up, is just to fire up that regulator on the bench, give it a small load, and then enable it, disable it, enable it, disable it, and look at the current going in. Because we're very concerned about current because we're running on a battery. And we want that battery to last as long as possible. So when we're in sleep mode, we want it to be as close to zero current as possible. And the processor is down in microamps during sleep mode, well engineered. I do not have an answer for what our fan regulator does yet, but I will report back. And that's on the docket for hardware modifications. The battery situation has been great. The fan, this cute little fan, has been great. It draws. It does draw at 5 volts. That little fan draws 45 milliamps, so it is not trivial. And we only use it for right now. We're using it for 45 seconds every time it takes a reading, and then we're shutting it down. And then we're taking a reading every 20 minutes. So it's an investment in power to run that fan, and we're going to evaluate what our return on investment is as we go through this process. So let's see. Greenwood AG says, do you suppose there is a spot that you can steal juice from in the AMS? Dale's been beating me over the head about that. And the answer is, I suppose there is, but I'm trying to not. So let me get to the point that I want to get to, which is pure battery operation, because I think it's going to result in, every 3 months you have to spend, you have to charge it overnight or something like that. It's not going to be a big deal. And then because it's a pretty standard input, you could even plug it in. I mean, the problem with plugging it into the USB-C connector is a mechanical one, not an electrical one. If you were using it in an application where you can get at the USB-C connector, which is on the bottom, right? We put it in the AMS like that, then no problem. You just go steal 5 volts from somewhere and pump it into the USB-C connector, and you're done. Okay? The problem is in the AMS, we're dropping it into this spot that's there, and you really don't have room to get to that connector, which means I'd have to wire out the side to do that. So it's a road that I could go down. I don't want to go down that road yet. I want this thing running on this magnificent 18650 battery, the most common lithium-ion battery on planet Earth, as a first step. I hope that answers your question. Yeah, Evil says, I don't get your objection to using the dry air input as the power source. Right, so we could put in a little turbine so that as the air comes in from the low flow system, it runs the little turbine. Yeah, that's not going to work. Nice try, though. So we're rapidly approaching the point where the electronics are going to be declared done. Almost there. A couple of current measurements left. The case is pretty much done. And then we could make tweaks in the software. For example, should I run the fan for 30 seconds, 45 seconds, a minute? Should the fan be running during the measurement? Right now, I turn the fan off, I wait 15 seconds, and then I take my measurement. I'm not sure. According to the Sensorion design-in guide, I can leave the fan on during the measurement, and maybe should. We'll see. As long as all these experiments are in the world of software, it's going to be fairly easy to do. So that's where we're at with that project. I'm very pleased with it. We have six AMSs to equip. So 6 AMSs. I want to put one in the environment, probably one in the reference jar, We're up to 8, and that leaves 2. So if I do a build of 10 units, I'm going to have 2 unassigned. That's not terrible, and we'll go from there. If this sounds like something you would like, let me know, and we could make it available in small quantities. I don't think it's going to be a product per se, because it requires skilled use, right? You have to, as soon as you get it, you have to plug it into your computer. It'll look like a USB drive. You have to go edit a file and give it like your Wi-Fi information, and give it, go give it the parameters of your system, and how often, and all that kind of stuff. So if it's something you'd be interested in, let me know, and maybe we'll get a group of, I guess we call it alpha testers, not quite beta testers, and you could play with it. So that's where we are. By the way, the material here, this black stuff, is the Polymaker Polysonic. Back in the 3D printing department, I looked up the difference between Polymaker PLA Pro and Polymaker Polysonic PLA Pro. The Polysonic is specifically engineered for very fast printing. I'm not sure we need that. So for the purposes of these products, this kind of work, I may, when I run out of the Polysonic, I may revert to the regular Polymaker PLA Pro. And one of the major things is the Polysonic comes in black and white. And the Polymaker PLA Pro comes in colors. So unless I'm specifically trying to print at warp speed, which I don't think I am, I may revert out of that, but we'll see what happens. Yeah, Ted cut and pasted some of his notes from P16 through P19. Absolutely. Ted knows about this. About all the P's. Anyway, I was very pleased with this. If anybody's interested in specific details about what I learned in the process, we could have a chat in the after party roundtable, or you can contact me directly. But this has been super as far as a fun project, a useful project. And when this thing is settled down and I could just put it into service and not think about it anymore, I'm out of a job. And I want to be out of a job because I just want to make stuff. Evil says, on a community note, have you had any thought about doing a Git workshop part 2? Yes. And I think I need it now, right? So when Ike gets back, he's traveling. We'll have that conversation, and I think it's a good idea to put it on the calendar. There's a couple other things that are going on the calendar that we're a little bit behind on. The problem process is coming up. I got to talk to our guest problem solvers, and we're going to schedule something for that. And let's see, we covered all that. Let's go to an AMA. Ask me anything. Anybody who is at a keyboard, feel free to drop in a question, any topic, and we'll see if we can't answer that in our last 5 minutes here. And we will give you an update. I have no major updates from the shop. Everything is actually very healthy. Mr. Okamoto has been just cranking. I've been so busy with PFG Stones, which reminds me, if you need something flat, head over to PFGstones.com and get something that'll make your bumps go down, if you know what I'm saying. So the Okamoto's been kind of flat out on stones. I have some grinding to do. I've got a couple of projects for folks. I've got a project for me. And I haven't done any regular metal grinding in a little while. Let's see. Any suggestions for a lost voice? Yes, tea and honey, and stop talking. That's about it. I like honey in my tea when I'm sick. That's about the only time I like it because I don't usually have honey in my tea. But yeah, just tea and shut up. How's that? I'm sorry. Yeah, Evils is feeling a little under the weather, and we hope he heals up really quick. Yeah, take the tea. Bill Only says, what welder do you use? I've been getting into welding a bit and looking for something entry level. Okay, so I bought my stuff is not entry level unless you want to spend the bucks. I bought a Miller, my very first welder. You're going to be sorry you asked. My very first welder was a Snap-on MIG machine. Okay, a little one, and I remember it was 75 amps. Now, what I didn't understand was this machine was aimed at auto body work. And, of course, I wanted to do aluminum. Do you see where this is going? So, first of all, if you're going to do aluminum, don't start with a wire feed machine at all. Number two, don't start with 75 amps. And number three, maybe you should get some training. So that was a complete disaster. I got rid of that machine and I replaced it with a Miller 180, the old transformer machine for TIG. Was that a magnificent machine? So that got me into TIG. I then after buying that, I took a course. So I had the machine at home. I was kind of futzing my way along, and I took the course. I was able to come home and practice, and that's what locked me into TIG welding. And of course, it would also do stick, but that was a great welder, and it would not blow away in a stiff wind. Okay. After a while, I sold that, and I bought the Syncrowave, not the Syncrowave, the Dynasty 200DX, which also is a TIG stick machine of magnificent results. Just fantastic machine, and I'll probably have that forever. It's been a great machine. Later, I added the torch cooler, so now I have a liquid torch cooler. I went to those type of torches, love that, and I'm having a great time. So I think I answered your question. Let's see. Oh, so as far as starting welders, I have no problem with things like that welder we showed for 1850. I have no problem with the so-called prime weld. There's a lot of welders out there at a lower price point. I think having a welder is more at a lower price point is better than saving your pennies for a long time to buy a higher end welder. I think you need to get on the machine. So I'm okay with any of those. I'm trying to keep up with you guys. Greenwood AG says, if you're using a battery holder or spot welding connection are you using a battery holder or spot welding connections to your batteries? I'm interested because I need to repair some of my Milwaukee batteries. I have not done any spot welding on batteries. There are others in our group that have. I am using the battery for this project that I'm doing. I'm using a battery from Adafruit, which comes already spot welded to wired up. There's a protection circuit in the very top of this thing, and it's got a connector. So that was a fancy way of saying I'm not doing any of that. So I don't have a really good recommendation on that. Liquid cooled torches are the way, says CJ Stevens. I am now a believer. They're really pleasant to use. Let's see. Ted Hyde says, excellent machine. Which one are we excellenting? What, the Synchro, the Dynasty. Oh yeah, Dynasty is just class act. I love it. Evil says, any opinions on used welders? As long as it doesn't look like it was, run over by a truck, they're probably fine. Even I had an infant mortality on my Dynasty that had to go for repair. That could happen. But basically, if you try it, it works, and it's used, and they're selling it, and you want to buy it, there's not much to wear out. DBX says, try Vivor right out of the box. They work like used. I don't think that was an endorsement, but I get it. Yeah. Bill says, got to get the time in. Yeah. When I took my course in welding, and there's a story about that, which I won't bore you with, but it was a really fantastic course. And my instructor did a weld, and I tried to duplicate the weld. And of course, my weld looked like some seagulls just flew over. And he did it again, and I did it again. And it was, I was learning. And he said to me these words. He says, the only difference between you and me at this point is a boxcar full of welding rod. We were doing stick. And that's what he meant. He's like, you just gotta do it, and then do it, and then do it, and then do it. It's like a lot of things, but I think welding is one of those things where there is truly no substitute for time on torch. And I think that's my opinion about that. I think we did it here. So thanks for being there, guys. I hope you had a great week. I hope you plan a fantastic week ahead. I know I posted this on Instagram, but we just this morning finished a dozen sets of 4-inch stones. I have to tell you, the majority are already spoken for, but there's some left for this week. So if anybody's interested in 4-inch stones, you got 3 shots to get on this week's load. And that's what's left. So let's see, looking for any more questions. One last comment on the Greenwood AG, the battery holder question. When I started designing the hygrometer and the box, you don't realize how much space a battery holder uses up. And I abandoned the battery holder, which I otherwise would have gone with, because I didn't have any space for the battery holder. And this solution from Adafruit was an awesome solution. Evil says, is there a place listeners can submit questions for the live during the week? The answer, yes. Send your questions on email to kp-contact@kineticprecision.com. That's kp-contact@kineticprecision.com. I can't guarantee I will be able to answer everybody's question, but we'll do our very, very best. I'll probably set up a slightly easier to remember email address, but that's pretty easy to remember. kp-contact@kineticprecision.com. With that, I'm going to wish everybody a fantastic rest of your Sunday. We'll see you guys next week. Get flat, stay flat, and we'll see you then.